thank you so much, Doris and team, for giving me this chance. I love engaging with the developers, especially the younger generation. As I said, I've been in the industry for about 13 years. Yes. And I believe what I'm going to share today is probably some things that I'm able to see. And I hope that I can make others see and I can influence them towards a specific direction. So when the webinar invite was shared, the topic was intersection of software engineering and telecommunication. So I'll talk about a lot about telecommunication stuff. I would like to say that I'm not the expert in this field, but the little I know I can share with you guys who probably are very green in that field. I'll also focus a lot on what we can do as software engineers. And towards the end, we will connect and share a number of things. I know I've also seen my seniors in telecommunication here. So when it comes to the question and answer question, in case someone asks me, what is PSK modulation in radios? Please, I didn't do telecommunication or electrical work. So I'll invite my good friends to come and share. So I'll talk about radio technology. We'll also look at telephony briefly. We'll look at GSM and GPRS architecture, the evolution from 2G to 5G, and why this matters. And at the end of it all, my objective is to challenge you guys to dive deeper and also get to see where we can plug in as an ecosystem. So radio technology, I'll just talk briefly about something called radio waves. You guys know radio waves. If you've ever bought a radio, then it uses radio wave. It's anything electromagnetic waves between 30 hertz to 300 gigahertz. So that caters for your radio communication, TV, walkie-talkies, your mobile phones, even the NFC devices, the RFID stuff that you guys have been reading or you probably have heard about. All these things are within the spectrum of radio waves. And in radio communication, I'll also highlight something very, very important so that when we get to the architecture, you might have an understanding on a few things. Communication can either be simplex, half duplex, or full duplex. So when one radio device is talking to another radio device, it can either be simplex when it is one-way communication, e.g. in this case, when you look at TV broadcasting or radio broadcasting, that's simplex. You have a transmitter at KBC and you have your radio somewhere in Bomet. So your radio is a receiver and the tower that you see at KBC building is the transmitter, and it can transmit very long ranges. So sometimes you might hear radio, other people in other countries, you might have heard of them calling them receivers instead of a radio. The other thing is walkie-talkie is also a sort of communication. So we have half duplex. There you can communicate one way. So a walkie-talkie is both a transmitter and a receiver, but it can only take the one role at a time. So when walkie-talkie A is a transmitter, B is a receiver. And the other way around, when now the other guy says over and switches the communication channel to go the other direction, that's half duplex. So when you talk about full duplex, it's mobile telephony that you're used to. And basically what we look at is transmission is done both ways. So I can talk as you talk. And even as we speak right now, SIP powered communication like Skype, Zoom, all these things, or even Google Meet, they are full duplex. So I can speak while the other people are also listening. So whenever you talk about radio communication, please remember there is a transmitter and a receiver. And a transmitter has an antenna and the receiver has an antenna. So you just have to ensure that there is no wired communication, it's wireless. So radio communication includes even Wi-Fi is also radio communication. So it's not, or even Bluetooth, that's radio communication. So it's not just GSM or even your TV or radio. So anything that has an antenna and the other side there is an antenna and there is wireless communication, that's radio. Even WiMAX and all those things, radio. So I'll talk about the brief history of telephony because we are here because of this, but I don't want to talk about 2G before you understand what used to happen before we were born. So there was a guy called an operator who used to be in a physical room, like an office, And inside there, that room used to be called the exchange room. So you'd find that if you have guys from JKUAT here connected through wired communication, then we have guys at UN. There are exchange rooms in all these universities. And the key thing is there are physical wires that have been connected from one room to the other. And if you guys found telecom communication before we got mobile communication, you remember those wires. So those wires could move from one room to the other. And the key idea is if Marlin, who has a line 0101, wants to talk to someone like Janina, who has 0302, Marlin would call the operator and tell the operator that I need to talk to 0202, 0302. Then the operator would talk to the operator at UN. Then that operator would talk to the operator at Dedan Kimathi, and Janina would be connected. As they are doing that, they have to reserve a line and they do a loop back. So I say this line coming from Marlin, I connect it to port 2. Then port 2 on the other side is connected to port 3. And then port 3 in DKUT is connected to line 0302, who is Janina. And once the connection has been set, the two people can speak. So that communication that happens is called the communication overhead. So the operator didn't need to talk. Marlin wanted to talk to Janina, and that was the intention. So all these communication that the operators were doing, basically that is what we call the communication overhead. So that overhead is part of setup, call setup, and it is very critical for you to appreciate that, because we will have a very serious conversation on that overhead when it comes to communication. So the automation was the next innovation, and the operator was declared obsolete. I guess he became a farmer at that time. And this was because of advancements in technology, and the switching could be automated. So later we went to circuit switching, where the operator was eliminated, and all that communication that was needed for call setup was automated using electronic technology. So that operator went home. Then the instructions to set up the wires was automated by electrical engineers. And the communication that happens for the setup is called the signaling. And once a channel or a circuit has been established, then we can have the voice call connected. Or probably you can hear a ringing tone and the other guy is connected and voice can go through the wires. So the key thing is the tearing down and the setup of calls requires a lot of signals as the ports are being reserved. And that communication is called signaling. It's not necessary for the people to communicate, but it's necessary for the setup. So there was signaling system number 1, 2, 3, 4. And today you might have heard about SS7, which is signaling system number 7, which are rules that allow us today, even in telecommunication, to G, 3G to communicate. So we had signaling system number 5, and the issue was signaling system number 5 used the same line. So the line that is going to be used for the communication was used for the signaling messages. And the issue was there was a security issue, because the people who are making calls could actually detect the signaling messages, and they could pick a few things here and there. So there was separation, and later we got something common channel signaling, or we call it maybe C7, or you can hear common channel signaling system number 7. Actually, from number 6 going forward, the signaling traffic uses a different line, and your voice traffic uses a different line. There might be a bit of complexity here, but don't worry, just know that the information to set up the call is sent through a different channel, and information to actually send the bearer traffic, the voice that is being produced by the two parties, is sent through a different channel, or you can consider wires. So we talked about common channel. I won't repeat that again. So the whole idea is that you have 8 wires from switch 1 to switch 2. 5 wires are reserved for the user data, our voice, and 2 wires are reserved for carrying signaling channel. So this is basically what was introduced in SS6 and in 1988. And today we use SS7 in our communication. So you'll hear, if you go into GSM network, you'll hear user plane, control plane. User plane is you as the user of the communication link, the voice is carried through that user plane. And the signaling information, the information used to set up the calls, is carried through the control plane. So if you talk about 2G, you normally have something called the mobile station or the SIM card in the phone. So you can think of the phone as the device with an antenna. It has a processor, it has everything. The SIM card is a microprocessor that has some memory, and it can be used even to store the phone book. Together they form the station. And that station talks with another station, which is called the base station, or sometimes we call base transceiver station. If you see the word transceiver here, by now you know we are talking of this guy can communicate both directions. So the phone and the BTS, they are two radio devices, just like your TV and the KBC tower, but they can communicate in both directions. So they are full duplex sort of a setup. The other thing that you need to note, because one of the key things that you'll hear is that you have 2G, 3G, 4G. All these things, they are advancements, but there is some common denominator. All of them, they have to deal with the question of mobility. And that's why it's called mobile network. Because one of the stations, as we saw, keeps moving and the other one is fixed. So when it moves, it can move from Nairobi to Kisumu. And once it moves from Nairobi to Kisumu, you have to remain on the network. So what happens is, for mobility management, once you switch off your phone, every technology, whether it's 4G, 2G, it has a registration of what you call network attach. Whether you're dealing with 2G, 3G, 4G, 5G, there is attach. So if you want to study 5G, you have to look for the equivalent. How do they do attach in 5G? Then handovers is when you're driving along Thika Road and you're being served by the BTS near Muthaiga Square, and you come all the way to KCA, there is another BTS there. You have to be handed over to the other radio device. So even for G2G, they have to answer those questions. Location updates, periodic location updates, that has to be done. Then sometimes you'll hear multi-RAT. RAT means radio access technology. So 2G is an access technology, 3G is an access technology, 4G and 5G, they have access technologies. And one thing that you'll know is that if you have a 4G phone and you have not enabled VOLTE or voice over LTE, so basically whenever you make a voice call, your phone moves down to the 3G to make a voice call, because LTE or 4G does not support normal voice calls. It does data only. So if you have voice over LTE, that's an IP call. But if you've not enabled voice over LTE, then at that particular point, you realize you're making a phone call, then your phone changes as you dial from 4G to 3G. So those things also happen, and each and every network must find a solution for those. The other thing is user data management. This is basically looking at the subscriber data, your SIM card information for security. Even in 4G, we have to store that information. 2G, we have to store that information. Session management, in case you're establishing sessions. In case you're doing 4G, you have to establish those bearer sessions where you'll carry your load when you're watching a movie. All those things, the sessions have to be established. So in 2G, you talk about the whole circuit has to be established. But in 4G, 5G, you talk about those data sessions being established. So each technology must answer the question of how session management is done. Then you'll also hear user plane or the bearer plane, and you'll also hear the control plane. Control plane is for the setup, when you're doing the session setup, session, bringing session down. So that's traffic that goes through the control plane. The user plane is the actual voice that you carry, or your data when you're watching YouTube. So when your phone is connected to 4G, you have that data attachment that has happened. Sessions are active. And now since the sessions are active, you can carry your traffic. So the traffic is carried through user plane. You'll also hear things like policy and charging function, whether you talk about 3G or you talk about 4G. One thing about internet is my voice might degrade here, but in GSM and mobile networks, the technologies are designed to ensure that there is quality of service. So you don't hear the voice, someone like the way you could be on Zoom or Meet and you have an unstable network connection. So in mobile communication, that is taken care of. and policy rules and control function. If you remember the days of unlimited data, but then you're capped at maybe 1 Mbps, those are done by the policy control function and other things that enforce that. So those are things that you'll see in all networks, whether you're dealing with 2G with Edge, whether you're dealing with 3G with HSPA and HSPA Plus, or whether you're dealing with 4G or you're dealing with 5G. These things have to be answered. So because now you understand what the mobile networks do, they basically allow you to move, they allow you to have your data on the network, they allow you, they authenticate you, they manage your sessions, they carry your voice, and they control how that is done. So we'll talk about the GSM architecture, the 2G, and we will use that template to understand what happens. So I will talk about the mobile station A and mobile station B. Those things that you've been calling boosters, don't call them boosters anymore. They're called base transceiver stations or base stations at times. And in a network, there are so many of them. And the key idea is that you have a phone connected to one and another phone connected to two. Now, inside there is base service controller or base station controller. And the work of the base station controller, it's connected to a number of BTSs, and the work is to control them. So this thing has an antenna, it communicates to the phone. But in case you move too far from the tower, then you see that your network connection becomes dimmer. And the base station controller says, hey, this guy is too far, can you increase the power? So this guy is the one who controls all these things. And even when you move from one site to the other, this guy is involved in the handover process. So the basic idea is that the BSC does the control. So the BSC is in a room. You don't see it with a tower because the connection between these two is normally wired. If you joined telecommunication early, we used to have physical wires, coaxial cables. We got to Ethernet, those IP, and now we even have fiber connectivity. So this is called the base station subsystem, which some people call the radio network or the radio access network. So in addition to that, the stations are connected to the switches. So in Kenya, we could have many BSCs in Safaricom and we could have many BTSs, and they are all mapped, like I've indicated. So you could have a switch in Kisumu and you could have another switch in Thika. And the basic idea is that a switch serves a number of BSCs. And there are things called location areas. So you'll have a location area 1, location area 2, location area 4, and these things are configured within the network. And the basic idea is that if you switch on your phone in Kisumu, you'll be in a specific location area. And another guy has switched on their phone in Thika, they'll be in that MSC area and location area being served by an MSC, a BSC, a BTS, and all the way they're connected to the mobile station. So the key idea here is that the switches are connected. So the operator and the exchange room guy disappeared and we got the switch here. So this switch, its work is to know that A wants to call B. So the key idea is that when A calls party B, so the request will go all the way to this switch, and this switch is supposed to figure out where B is and route the call to switch 2, and then the call is routed to the BSC, and the BSC does the paging to discover which phone has that identity. So if you're in a room and someone's phone rings, then the reality of the matter is all the phones in that tower or in that location, they were all paged. And paging is like what people do with the doctors. So you get paged, so your phone is supposed to buzz. So all the phones receive a message, but the one that is the owner of that identity returns a message back to the BTS and the BSC to confirm that I am the one. And once it confirms, then the call can be established. So the key idea is that the whole process of setting up a call is very procedural and well documented, and you don't need to worry so much about whether you need to be a master. No, you can read and the documentation is written there. But now I talked about this switch figuring out where this phone is, or phone B is, the MSB is, or the B party is. So we use a database. We have databases within the network that store all the subscribers. So when you buy a SIM card and it's activated on the network, you have your own profile in a home location register. So this is a store, it's a DB that has all the profiles. And whenever you switch on the phone, the switch talks to the HLR and gets your profile and loads it into a thing called the visitor location register. So both of them are DBs, but then the key thing you need to know is that the visitor location register is close to the switch. And what it means is that if I have 10 guys who are roaming, and allow me to use the word roaming, within this area, then the network, the profile of the guy who is connected to this switch, all of them are here. So if your phone goes off, the data can be purged from here, but here it will always be there. Another thing to note is that, you know, sometimes you could have an MTN Uganda line, and you come here in Kenya and you roam on Safaricom network. So if you're in the Kisumu switch using the MTN Uganda line, then your record is in MTN HLR. But since you're connected to Safaricom switch, then definitely what happens is that the VLR has a copy of your record. So you can think of a VLR as a place where we download your profile from the HLR and we put it here. But at what point do we download it and put it in the VLR? The day you switch on the phone or the day you register on the network. And the registration process does not just involve HLR. It uses something called AUC, or the Authentication Center. When we talked about the radio call, the OVA, those radio calls that the security guys use, those things don't have a SIM card. They are not secured. And if you tune to the frequency they are using, you can hear what they're saying. But in mobile telephony, everything is encrypted. And what happens is that the SIM card is a processor. It has security keys inside the mobile station. And those keys are also within the AUC. And the basic idea of being secured and to be allowed to get into the network, all you need is to the network will give the phone a mathematical challenge. And it has to use the keys that it has. Then it will send back that key to the network. And the AUC will also do the same mathematical challenge using the private keys that are stored on that place. If the two challenges are the same, you're allowed to get into the network. And at that point, we update the VLR, and we also update the HLR to say, now this guy called Brian is in Kisumu and he's being served by this VLR, and the HLR has a copy of that information. So the other thing is, there was a time the CA of Kenya, or the CA nowadays as they're called, blocked all fake phones. So we also have equipment identification register, which is the place where we configure the IMAs, ranges, and just to ensure that if you bring a fake phone or a counterfeit phone, then during the attach process, during the registration process, we can block that. So that basically gives you an overview of how the GSM network works. Please take note, people can call now, but we cannot bill, we cannot send SMSs, because here we have not talked about how SMS network looks like. So here we've looked at how the voice network looks like. So let me just do a basic simulation. A dials the number for B, and that request comes all the way to the switch. The switch asks the HLR, can you send me the routing information of B? Because when B connected to the switch, it also updated the HLR. Please note, there is no line between this MSC and the HLR, but all the switches have connections to these boxes. So what happens is that the switch serving the A party will ask the HLR, can you tell me where the B party is? And we know the B party because you keyed in your number when you're making the call. So you'll get that information, and the telco guys will confuse you when they're saying SRI. They like acronyms, but it's just send me the routing information. You get it back, figures out that this guy is in Thika, forwards or basically establishes a connection, a circuit between the switch here and switch here. And that connection is reserved for this guy. And then this guy talks to this guy and does the paging. All the phones receive the signal. The right phone responds. And then once the paging has happened, a connection is completed and the whole circuit is completed. And once the circuit is completed, the phone B starts ringing. And once it has started ringing, once you pick, then the voice can be carried through the user plane or the bearer channels. Remember, when the signaling was happening, we were using the control channels. So don't worry about that, but just remember that control is when you are doing the overhead of setting up and tearing down the communication circuits. And the user plane is when the circuit has been established and I want to say I have missed you. So if you want to connect to, assume this is Telecom Kenya, you want to connect to Safaricom, then there is a guy called Gateway MSC who has the same function as an MSC, but is on the edge, and you can put some controls there to prevent an attack from this network. Please note, this network is private. The guys who are used to TLS in IP network, you know SSL, I'll shock you. Within the telco, all the communication, most of it is not on TLS, especially on 2G, 3G. I believe now as you go to 4G and 5G, the conversations are changing. But it used to be a private network, very unsecure. You could eavesdrop and you could listen to any packet. This should not shock you. The telcos got you covered. So PSTN is if you want to call the landline or public switched telecommunication network. PLMN is public something. They're just acronyms. Just remember PLNM is Safaricom is a PLNM, Airtel is a PLMN, and don't worry about the naming. The acronyms you can Google. So what we have here is the core network, or some people call it the network subsystem. So you can hear BSS. Please don't confuse these with the guys who deal with CRM and they say the business support systems. No, this is base station, subsystem, and core networking and NSS. So let's make an addition to see how SMSs work. So for SMSs to work, what happens is the same network is enriched with another box called SMSC, or the short message service. Those of you who have been saying, send me an SMS, you're wrong. You should now start saying, send me an SM, because the short message is the actual message. SMS is the real service. So when you talk about the SMS, we confuse it, but it's actually the service. The SM is the short message. So when you hear SM in telecommunications, it's just short message. So the key idea is that this short message stores messages and forwards to the people. So the basic idea is that if you have the first phone that wants to send a message to the second phone, the message will be relayed all the way to the switch. The switch will discover that this is not a voice call, it's an SMS service, and it forwards it here. This guy has a DB and stores the data. Now, what happens is that the SMSC, just like the switch, can actually ask where B is. So the SMSC can also ask the HLR. I know there is no line here, but there is another line between the switch and the HLR. It can ask, this B party, can you send me the routing information? And at that time, we'll say send an SRI for SM. Send routing information for short message purposes. And this guy will be given the details of where the B party is. If you're in Kisumu and you're being served by the Kisumu switch, this SMS will forward the SMS here. And if in the event your phone is off, the SMS will store the message. And once it stores the message, it will eventually wait for you to come to the network. And sometimes HLRs have a way of notifying the SMSC. You can alert the SE or the SMS center, and you tell it that this guy has come back to the network. If the SMSC is informed that you're back on the network, so the SMSC now goes back to the DB, looks for all the messages that were meant for you and sends them. That's when you switch on your phone, you find that you receive so many SMSs if guys sent you SMSs before. It's because of these SMSC that has the capability to store and forward. Now, the other thing I would like to highlight is what I've just described here, but I'll just show you very briefly on what happens between when you're sending an SMS from a person A to B. So I'll come here, there is a network, there is the switch, the VLR, the visitors of that switch, the people who have visited there. And once you send an SMS, it goes all the way from the BTS to the BSC, represented as the network there, and it goes to this guy. This guy, called the MSC, forwards to the SMSC, as I said. So there is something called MO, meaning it's mobile originated forward short message, or we are submitting the message to the SMSC. And then, of course, the SMSC acknowledges to the switch and says we have received it. Now, what the SMSC does, it will go to the HLR and ask for, where is the B party? And this guy will receive the information about B party. And once you receive B party, what do? You forward. Now we say it's mobile terminating, because when you originate, the other guy is terminated with SMS. So you have MT, forward short message, or we are delivering the message to this guy. And then later we do this, and we get the delivery receipt. So anytime you get a delivery receipt, it comes all the way from this side, and the MSC will do the paging as usual, figure out where the B is, and forward the SMS. So this is a critical element, and I know we've not talked about the call flow for voice, call flow for GPRS, but in telco, you must understand the call flows. As people in IT, we like creating our own custom APIs. In telco, everything is well defined, and the APIs are very specific, and the parameters are very specific. So you actually don't need to think much. You just need to comply. Now that we've seen the SMS, I'll briefly talk about GPRS. And I have captured another diagram. Now we already have the mobile station, the BTS, the BSC, the switch, the gateway SMSC, all those things. So we have added 2 nodes that take care of GPRS. For those of you who might not know what GPRS is, when you used to browse before we got 3G, you're basically on GPRS, or it's called, I think, Global Packet Radio Service. It's just a way of sending packets through our network. So there are 2 things: the serving GPRS service node or something, and then there is the gateway node. So basically what happens is that this node here, there could be many, just like we saw that the switches could be many in a network. The SGSNs could be many. They are the ones that maintain the sessions. So whenever you're browsing and your phone has the data link on, and if you're on Edge or 3 or 2G, so the SGSN has your session there. And once it has your session, if you're browsing to Facebook, it will forward the traffic to GGSN that will forward to the packet data network, which could be either an internet or it could be private network, especially guys who are using the SIM cards. Like banks, the ATMs run on such stuff. So what happens is that on the HLR, the bank SIM cards are created with a profile to say that they have things that we used to call APNs. They are basically connecting to KCB private network. And if you're browsing and watching a YouTube video, then the GGSN connects to the public network, which is the internet. So you can have both private or this, and the GGSN can route accordingly based on the profile on the HLR. Remember, we said that when you location, you do an attach to the network. The switch has your profile in the VLR. Even the SGSN stores the same information. So they don't have a VLR, but the SGSN actually stores some profile information. So basically what we do is we download your profile, we put it here when you do the attach, and that attach is called the GPRS attach. So when you're connecting to the network and your phone is going on and you enable data, you basically have attached to the data network. So that's how the GSM and Edge radio access network looks like. And that's what we call 2G or 2.5G, depending on what you have been reading. So when we talk about GPRS and Edge, this is how the network looks like. So the key functions are, the mobility management, all those things that we talked about, the subscriber data management, all those things are mentioned there. In addition, there are some few elements which I have not highlighted here, but you don't need to worry. So on the network, there is a billing and charging. So there is something called the OCS or CBS, where your airtime sits. So your airtime doesn't sit in the HLR. It sits with another system called the billing system, or the converged billing system, or the online charging server or something. Then you have USSD gateway, which works. It's like the SMSC just connected to the switch and is able to do now USSD sessions. And it's able to interact with your bank if you build USSD applications, and you can forward that USSD request to your application. PCRF, as I said, the policy, the rules, the QoS, those nodes are there. And then there are things that are called STPs. So normally you find that the network has all these switches, but sometimes the switches are not connected in a mesh. So all switches connect to the STP. The STP routes the traffic to the other switches. So it's like the way you connect to one router, and through that one router, you can talk to so many servers like Facebook, Google, YouTube. So the STP is basically the equivalent of a router within the IP network, for those of you who understand the IP network. So that's it. And the key thing is I am done with dealing with the network. So majority of the things that you need to know by now, you know. So the only thing that we are going to look at is basically the slide changes, and I'll go very fast on how 3G looks like, 4G looks like, and 5G looks like. And then after that, we can talk about why we are studying these things. I know you guys are Python developers. Why are we even telling you about 4G and 5G? So 3G is called UMTS, or I think it's Universal Mobile Telecommunications Services Network. And it's also called Universal Terrestrial Radio Access Network. That's the RAN, or the radio access network. So you can consider the RAN is on the radio. If some of you are observant, you will realize that this diagram looks like the 2G diagram. The only difference is that instead of the BTS, we have a node B. I don't know why they called it node B. Maybe the telco guys here could tell us whether there was a node A that didn't work. And then we have the radio network controller. So it's like the base station controller. The work is to control the node Bs, and the rest is the same. So the key idea between 2G and 3G is the radio changes. That's why you have the UTRAN or the UTRAN. And the stuff that happens there is different. Before then, when you have a frequency in 2G, one frequency could have 8 slots, and each of us could call using those 8 slots. And those 8 slots were time slots. So it's called the time division multiplexing, being able to push our voice traffic using one frequency, 8 of us. And that's what we call multiplexing. But here now they use something called scrambling codes, or the CDMA, if you've ever heard about CDMA. It's just code division something access. But it's basically multiplexing. But it's basically you're giving each and every person a code, and they share the frequency. So it's much faster than 2G, and you can do higher speeds in 3G network compared to 2G network. When you go to 4G, a lot happens. Now, these guys were, remember, it was circuit switched. You have the switches and all that. And you can do a voice call even if you don't have the GSN and the GGSN. Now, these two nodes are the data nodes. These things are called the circuit switched nodes, the RNCs, the MSCs, or some people call the circuit switched core network. These guys here. And these two nodes, they form part of the packet switched core network, because we deal with the data when you're browsing on data. Don't worry about the naming of the interfaces. They have specific names. Like I said, telcos are very specific on naming, and the standards are well defined. So the key idea here is that you can do both a normal voice call without the data being on, and you can do data when you switch on the data. But in 4G, it's fully data. There is no circuit switching. So the key idea, and that's why I talked about the RAT fallback, or the radio access technology fallback. So if your phone has 4G, definitely it has support for 3G. So when you are connected, you're actually connected to 2 radio networks, or you attach to 2 radio networks, both the 4G and the 3G. If you make the voice call, your phone switches down to 3G. When the call is disconnected, it goes back to 2G. But the key idea about 4G is, and this is the exciting bit about the software developers, this thing is fully IP. So we are not talking about, SS7 anymore. We are basically talking about protocols that we know, e.g. SIP, the protocol that we use for this call that we are having here, the protocol that we used for the WhatsApp call. So those are things that as developers can create. So there is the serving gateway, which you can think of this GSN. Every guy must have the session created here. And the PDN gateway, or the P gateway, is packet data network, like internet, like private network, and another thing called IMS, which we'll discuss briefly. So this guy basically connects to data networks. For 4G, there is no non-data communication. And the MME is the equivalent of, I would say, maybe the MSC, the VLR, for the sake of mobility management. So locations and all those things are defined within the MME. So the MME is used in signaling, or the control plane, and the SGW and the PW and the PGW, they're used for the sake of just passing your traffic, your MBs to Facebook or YouTube. HSS is the equivalent of the HLR. It's the home subscriber server or something. And the key thing that I was telling you when I started is that they might appear complex, but you have to go back to the functions we highlighted, and you ask yourself, how does 4G treat subscriber data management? And the HSS comes into play. How does it treat mobility management? And we talk about MME. If I expand it, there are all these things. The MME is used for signaling, for location attach, for location update, and all those things. But now once you start browsing, once the session has been created, your traffic moves through the E node B all the way to SGW, PGW, and to Facebook. But as you move, there is those guys who enforce the policies, the control part, and creating the rules, and the enforcement, policy control enforcement function, policy control rules function. So this PGW works with these guys to ensure that if you are limited to 1 Mbps, you don't go beyond that. If you have certain rules that have to be followed, you don't go beyond that. And I will not talk about IMS. When I talked about the voice over LTE, for some of you, when you have those 4G phones, there is a thing that you can activate called VOLTE, or voice over LTE. So voice over LTE uses this thing that we call the 4G network, and it's normally called the evolved packet core. And this is the evolved node B. And now we don't have a node B and an RNC. Both of them are combined into one box that can handle both a bit of mobility, and some of the work is moved to the MME. So in this 4G, you don't have two things on the radio. You have one thing on the radio that connects, or the evolved UTRAN that connects to the MME, and the MME has some mobility management, and the radio thing has mobility management. So it's like we lost the RNC or the BSC, and we just had those two nodes. So these things are, all these nodes here, they are part of the evolved packet core, which we have talked about, and it's all these nodes that allow you to just send data. So there is no circuit switching in 4G. So if you do a circuit switched call, it basically means that you have to fall back to 3G. IMS is another box which I'll not talk about, but the key idea is that when you have VOLTE, you need to set up the IMS. So for networks that have 3G and they want to set 4G, they have to do the nodes for the EPC, as we have seen. They have to install them, and they also have to install the nodes for IMS, which I'll not focus on. But the key idea is, think of these as SIP proxies and SIP servers. For you guys who might have studied SIP, when you're dealing with those voice, the connections within the IT world. So you can think of these things as SIP proxies and SIP servers, and they help you make the digital, the packet voice call, the packet switched voice call, the voice over LTE, or what some people would call the voice over IP, because LTE is an IP network fully. And for 5G, I'll also not talk about it so much. I know Safaricom I had consulted. So what happens is that you could have the 4G core, but then you add the 5G radio. So in Kenya, this is what has been implemented today. So it's called Non Standalone implementation, where you just add the radio that is 5G. And once you add the radio that is 5G, the modulation that happens, or the frequency magic that happens here, gives you super speed compared to the 4G radio. So basically you can increase the 4G radio and still use these other guys here, because most of the time you'll find that the core network uses fiber. So there is a huge capacity for backhaul. So if you increase or you change the radio network, then you're able to get those things. I will not talk about this, but I'd like you to note one thing. In 5G, things are called FFF. They mean function, like access mobility function. So this is a service that deals with the access mobility. Remember what the switches, the MSCs and the VLRs used to do, the MME is doing. In 5G, they have AMF, and you have SMF that is supposed to deal with, I think, subscriber management function. That's where we have the data, the PCF, where you have those policy control function. So the basic idea about 5G is that now, instead of having fewer boxes, you have too many small boxes. So the guys in IT should be excited. This is where we get microservices. So 5G network, you can think of it as very many microservices. And the greatest news to us developers is that the specifications for these interfaces, they are no longer SS7 interfaces. They are basically HTTP interfaces. So you can actually create a HTTP interface, HTTP2, but the APIs are well defined. They're not like the way you guys decide to create your own API that looks the way you want. Here, the APIs are very well defined, and the function is very well defined. So that's good news for us who are the developers. The key thing you need to remember, call flows mean everything in telco. The interfaces, then the message structure, They are all very well defined. So if you don't understand them, you can't say you know much. And then the functions and the interfaces are well defined, meaning that you can remove an EMF from Meliora and put one from Ericsson, and the service will work as usual because the APIs and everything work the same way. Call traces, very critical. So for you to be able to know those arrows, you know, SRI, how does an SRI request look like? You need to get comfortable with that. And for those of you who are familiar with Wireshark, it would give you a good advantage if you're dealing with a telco. Loving the bytes would be a good idea for you to interact with those hexadecimal numbers. You must be good at them for you to master these stuff. So I've talked so much about so many things. If you forget anything else, don't forget what I'm going to say after this. Of course, you're going to record this. We'll have a video recording, so you'll have access to this. But the reason why this matters is because, one, the network is moving towards IP. And you guys in IT, this is your space. 4G and 5G is a fully IP network. And this is our space as developers. So it doesn't mean that we have to wait for other countries to actually build those services. We can. The current telecommunication interfaces, think of them as APIs, those SRIs. They're actually APIs, only that they are not HTTP, they are not JSON, they're not XML. But they use SIGTRAN if you're dealing with, or the SS7 and you carry over SCTP. So you can create a socket. I know you know UDP sockets, you know TCP sockets. You can create SCTP sockets and you send bytes over the network. And by doing so, you can actually create 2G and 3G. This is not 4G, it's 2G and 3G network elements. So you can create a switch, you can create an SMSC, you can create a SSD gateway if we dive into this thing. Of course, we know sockets. Diameter and SIP, this is what controls things in 4G. Those interfaces and arrows, they are diameter and SIP for those LTE and IMS networks. And they're done by the same body that does OAuth 2 for the developers here. And the same body that does things like HTTP is all HTML, done by the same body. So the language is the same. So it's our space. 5G is supposed to use HTTP2. I'm not sure whether they'll move to HTTP5, but this is our space again. All communication is in bytes. So if you understand sockets, I know some of you here, you're good developers and you do sockets, you can become masters in telecommunication development. 5G services offer specific functions. We can see 5G moving to virtualized. Actually, there is a lot of virtualization within the 5G. And I believe one day we will be deploying our services on OCP, or the OpenShift container platform, using either those Docker or whatever container engine that you're having, or Kubernetes. So these are things that are coming. So we must dive into this space. The need for cost reduction, voice SMS revenues are going down. Go to the whole of Africa. Safaricom is an outlier, but most of the telcos are really suffering. So if you guys can build affordable solutions, then you're in business. The other thing is you need to appreciate the bytes for you to do this. You need to read the documents. If you're not willing to read the documents, this is not your opportunity. You can build services. So you have to start building these things. Let's do SIGTRAN. In Africa, 4G is not deployed in most of the countries. Kenya, we are quite ahead, but there are some places where they still have 2G and 3G. And I can predict, acting like a prophet, that in the next 10 years, we'll still have 2G or 3G networks being there. So if you want to help those guys save on cost, we can build stuff. 4G and 5G, we don't have an option. It's our space. But understanding the protocols and being able to do those APIs is not all. We need to be able to do high TPS systems. Can we sustain 200,000 concurrent sessions at the same time with our systems? So these are questions that you have to deal with because they're important. So what am I doing to ensure that you guys get into this space? I am here today to ensure that I encourage you guys to know that 2G, 3G, 4G, and 5G, just like the way you guys love fintech, this is also a thing that we could be talking about. We can master it. I'm also sharing my skills and knowledge. I have shared a bit of what I know and a bit that I have read. But as a developer, there are some call flows that I'm quite conversant with. We've done diameter development. We've done SIGTRAN. We're doing some trials. So we are doing those things. But the key thing is, I've done a series, and some of you might be aware of it. If you don't know it, you can go to YouTube and look for Natujenge. And my first step is to help you guys love the bytes and protocols. I've done part 1, love the bytes. You can look at it. So there are 2 more sections to go. And I hope that now that we have seen the space for SIP diameter, SIGTRAN, and HTTP, we will do some series on those protocols to help guys appreciate. Pushing you further, we did a hackathon to help you guys deal with. I know some of you are wondering why you are learning about SCTP 1 week ago. So this was because we needed you guys to push yourselves so that you get into this space. So challenge yourself, do encoding and decoding of SIGTRAN stack, so we can do those, the SS7 layers, and we can decode them using Java, C. I saw guys doing a lot of Python, which was quite encouraging. So those are things that we can do. And what I mean by that is that this in itself, this is a Wireshark trace. How this is as an SMSC talking to a HLR, and then the HLR sending the routing information in frame 2, and then frame 3, this is the SMSC talking to the switch. So it is invoking forward SM. If you remember the diagram that I had shared earlier, there was forward SM for MT. So this is basically how those interfaces look like. I know some of you might have done Wireshark traces. You've seen a HTTP request. There is no difference. All of them are hexadecimals, as you can see here. And it is our space. So I'm here to tell you guys that it's our space, and I'll not stop here. So if you guys are interested, you can watch more videos. There is a YouTube channel that has very, very good content that I borrowed quite a lot of stuff, especially on 4G, 5G there. So these, you can go look for these guys, and they have a lot of references, and you can hear more about that. And the key idea is, if you're interested in learning more about this, you can drop us an email on Natujenge. We are basically having an intention to build or to Jenga those things. So you can send us an email, and we can have conversations on that. And thank you so much. Doris, I know we have passed our time, but I hope that the many, many words have been helpful to someone.
Thank you. Thank you, Kamochu, for that. Thank you all. Thank you, everybody, for joining. And I hope to see you in our next meetup. Goodbye.